Okay, so last time we already learned about kinematics of linear motion. Most part of the topic we already learned. In fact, we already up until 2.3. So 2.3, like I told you before, 2.3 is about projectile motion. Are you guys ready or not? Can we start?
Yes.
Okay.
Yes, sir. Yes, sir.
Alright. So projectile motion in normally I will divide into two parts lah. One dimensional, not one dimension, one component, which is y component. Another one is about x and y component, so two component lah. Okay, so for y component, we already learned this one. I show you the example already, which is about freeform. This is basically a freeform. Where we discuss the three equation, change to G. A to change to G. So we end up with these three equations instead. So I just rewrite to remind you guys. So it will be V equals to U minus GT. Okay, and then we have V square equals to U square minus 2GS. And the last one we have S equals to UT minus half GT square. Again, kalau saya salah betulkan. Okay, so this one we already learned. I already show you an example on how to solve the question. So today we're going to proceed with the X and Y component. So this one ramai orang anggap yang this is the actually series of this chapter lah. But for me, okay je, tak ada masalah pun, it's okay je. So don't worry too much. But you need to understand the concept. Kalau tak faham, tolong cakap lah. So I will try to go. So today I would like to focus more on concept, not the quantity. So macam last time, I think I try to do as many questions as possible. But this time I would really like to make sure that you guys understand. Okay, kita discuss. Okay, enough with the introduction. So for X and two component punya motion, okay, so the easiest example, the most common one would be, let's say if you have an archer. So let's say archer ni, they point dia punya arrow in this direction. Okay, so this arrow is not in the X component, it's not in the Y axis. Okay, and then you will expect that this arrow will travel roughly in this direction, maybe in this direction, and this is the path. Then they will end up, katakan this is a level playing field, satu level. So this arrow will end up over here. Okay, so the initial position, normally we call this one as our U for velocity lah. So let's say the U is given. Okay, so if you want to solve this part, this type of question, the first thing that you guys need to do is that you have to draw lah. That was the first thing. Okay, number two, you have to take out information macam biasa. And number three, you have to separate X and Y. Okay, and then number four, you can use, you can find a substitute inside the equation, and then you can solve. Okay. Okay, let's say if you want to resolve into X and Y, so you will end up with something like this. You will have UX in this direction, and you will have UY in that direction. So normally the question will ask you to find the velocity over here at the maximum there, find the velocity over there, ataupun sometimes they ask you to find the range over here, the maximum height. Okay, nanti kita akan pergi satu persatu. And so that's the idea lah, apa soalan yang boleh tanya. Okay, now previously, if you guys still remember, we have the three main equation. So I'm gonna rewrite it. This over here. So V equals to U plus AT. V square equals to U square plus 2AS. S equals to half. Okay. S equals to UT plus half AT squared. Okay, so this is the general equation. This is the equation that will be given in the formula sheet. Ada lagi satu equation, which is S equals to half U plus VT. Okay, this equation is not given in the exam, in the formula sheet. You can use this one if you want to, if needed lah. But then you don't have to. So normally this three is enough. But this one, if you want to use, there's no harm. But it's not given. But anyway, I'm gonna erase this one. Okay. So this equation you can separate into x axis for x component punya equation and y component punya equation. Okay, one of the key criteria that you need to understand, key concept that you need to understand, this ux, okay, this arrow lah, this arrow once it's being released, kalau dia dah dilepaskan, it will travel in this direction. Apakah force yang ada acting on this arrow? Force apa yang acting on the arrow? Kamu rasa? What do you think?
Resistance.
Apa dia?
Dengan udara.
Okay, betul. Okay, kalau logically, we will have air resistance lah, obviously. But for your syllabus, kita assume there's no air resistance. And the air resistance is negligible lah, kita ignore. Okay, lain force apa yang acting on the arrow?
Kinetic force.
Sorry?
Kinetic force.
Kinetic force. Betul?
Okay.
Saya tak dengar sangat suara macam breaking sikit.
Kinetic force.
Okay. Kinetic tu sebenarnya adalah energy. So macam kalau dia bergerak kan, so itu adalah energy. Force ni lebih kepada daya yang ubah dia punya arah dia tu, maksudnya lah. Okay, kalau saya tembak ni, okay, let's say if I release my arrow in this direction, if there's no force, arrow ni akan gerak straight tu. Macam tu. Keluar
kalau gravitational force.
Okay, gravitational force, correct. Okay. So, in fact, the only force acting on this arrow will be gravitational force. Air resistance tadi kita ignore. And then, dia once kita release, kita biarkan dia bergerak sendiri. Sama macam konsep free fall lah. Once you release, you just let it be. So, the only force acting on this arrow or any other object is the gravity. So, gravity tu direction ke mana?
Downwards.
Okay, downwards. Okay. Kalau dekat tengah-tengah ni, dia downwards lah kan. Kalau dekat ujung sini pun dia downwards juga. So, gravity always downwards. Cukup banyak sedikit ujung. So, ingat, direction of gravity always downwards. So, ada tak? So, G ni sebenarnya adalah acceleration, acceleration ke bawah. So, ada any force acting on the horizontal component? Ada tak force yang ubah dia punya hal laju horizontal? Once dia dah release, tak ada kan? So kalau tak ada, maksudnya acceleration untuk X adalah 0. So key thing here, no force in X component. Okay. When there's no force acting on the X component, X direction, AX is equals to 0. When AX equals to 0, what happened to my velocity? So Vx is equals to?
Constant.
Yes, constant dengan yang asal kan. So asal dia adalah Ux, so dia adalah Ux. Okay. Okay, ini benda ni yang dekat right hand side ni dia tak akan sebut dalam exam. Dia tak akan sebut dalam question. This is the things that you need to know lah. kena faham, kena understand, kena pegang. Ni konsep dia. Okay. Ada yang tak clear tak pasal ni? Any question?
Faham sir.
Firas okay?
Okay, okay.
Okay, kalau tak okay cakap je. Nanti kita boleh ulang, don't worry. Okay, that one is for the X component. So there's no force acting here. So if you have the three equations, so I'm going to write this equation in terms of X component. So I'm going to write this one as Vx, Ux, Ax, t. Vx, Ux, Ax, Sx, Sx, Ux, Ax, t. So notice that the t tak ada subscript because the t is a scalar. It doesn't have any x or y component. Okay, and then for Vx ni, maksudnya kalau this is my final position, my Vx would be in this direction lah. Okay. Kalau Ux ada, dia ke bawah lah. Tapi kita tak cerita pasal Ux. Sorry, kalau Vy, maafkan saya. This is V. Okay, so Vx is over here. Ux is over here. Ax is equals to 0. Sx is actually the distance, the range. And sometimes they pakai term range tu. So this is your Sx. So I just introduce the term in terms of the diagrams lah. Kat mana location dia. Okay. So what happen when Ax is equals to 0? This term becomes 0. This term becomes 0. This term becomes 0. Okay. So you guys will end up with, tak muat tak? Saya naikkan semua. Okay. So you guys will end up with yang equation number 1 ni. You will end up with Vx equals to Ux. Okay. Sama lah macam yang kita dah decide tadi this one. So this one in terms of formula. Yang tadi tu more to logical thinking lah. Okay, and the second equation sama juga. This one equals to 0. So square kat sini you can take the square root. So it becomes Vx equals to Ux. It's the same things. And then another thing is this one. Sx equals to Uxt. Okay. So for x component, you only have two equations. Vx equals to Ux, and then Sx equals to Uxt. This equation will not be given in the exam. Dia tak diberi. So you have to derive. Tak ada derive. You have just to have to take it from here. Anggap yang A tu equals to 0. Apa yang dapat, tinggal ini je lah yang ada. Okay, ada soalan tak? Kalau tak ada soalan, kita try tengok yang Y component pula. So what I'm going to do, I'm going to copy this diagram, bring it down there to the new page. Okay, so the same situation. Okay, now you know that there's a force acting in the Y component. So for this one is for Y component. Okay. So you can treat this situation separately. X dengan Y tu kita boleh treat dia separately. Okay, yang Y ni you can treat dia macam free fall. Macam X tu kan sebenarnya ada satu contoh. Ingat tak dulu saya pernah tanya kamu? When you are sitting inside a car, and then what happen when you release an object dalam car? Ingat tak?
Ingat.
Ingat.
Macam kan? So, okay. Say like this. Okay, katakan kamu ada phone, kamu drop. Okay, ada yang cakap dia ke belakang, ada yang cakap dia jatuh straight, ada yang cakap ya ke depan tak ada lah kot. So, what happens then, actually, kalau car ni, dia move at the constant velocity, if V is constant, phone ni actually akan drop exactly below. Dia tak akan bergerak kiri kanan. Dia akan jatuh straight and dia akan hit the ground exactly where it should be. The reason is because bila kamu pegang phone ni, before kamu release, sebenarnya kamu ada UX in that direction. This UX is actually equals to the speed of the car. So you are basically holding the phone, so at the same speed with the car lah, you are moving at the same speed with the car. So when you release, this phone actually ada UX. Kita je yang tak perasan. So bila dia lepas, the UX will remain constant. Okay, that's why I told you, as long as this car is moving at the same speed, dia akan jatuh exactly over there. Faham?
Faham sir?
Kalau dia accelerates, obviously phone ni akan tertinggal sikit lah. Dia jatuh kat belakang sini. Kalau tiba-tiba dia brake, jatuh kat depan. Kita je rasa dia jatuh kat depan. Sebenarnya tak adalah jatuh ke depan. Okay. Saya padam this one. So kalau X component is like that, kalau Y component you can treat it like a free form. Okay, in fact yesterday tu kita boleh letak Y punya formula. Contohnya formula semalam kan kita ada V equals to U minus GT, and then we have V square equals to U square minus 2GS, and then we have S equals to UT minus half GT squared. Okay, so yesterday we used this formula, but if you want to differentiate between X and Y punya formula, you really need to put the subscript lah. So UY, BY, G tak ada lah. Okay, just put a Y over there. Okay, so this one is basically the same formula like yesterday for a free form. Cuma this time I put a subscript because I want to differentiate with the X component punya equation. Nak bezakan. So dalam example kamu boleh letak juga lah. Okay, now let's look at this situation. Okay, there's few things yang kamu kena tahu juga. Number one, dekat maximum here. Okay, this is a maximum height position, and at this particular position, Vy is equals to berapa? Cerita ke? Guys?
0.
Zero. Siapa yang jawab? Macam dia macam zero. Siapa yang jawab? Tak keluar nama. Are you guys okay? You guys still with me?
Okay, sir.
Bila sikit sir.
Yes, sir.
Okay. Tak, tadi siapa yang jawab zero tu?
Saya,
Saya
sir.
tanya. Oh, Syaki.
Asif.
Asif, sorry. Okay, Asif, kenapa kamu cakap zero?
Sebab dia dah atas, lepas tu dia akan berhenti turun balik.
Betul? Okay, so even though benda ni, saya rasa saya punya internet lost dekat saya punya laptop. Kamu mesti dengar suara saya?
Dengar, sir.
Tak apa, it's okay. Sebab iPad saya ada line lagi kot. Hopefully ada. Kalau tak ada, cakap saya. Macam ni kamu nak cakap Anyway, saya pakai wifi sama. Okay, so even though this one is moving, like it is at the same time it's moving to the right and at the same time it's moving upwards kan, but you have to treat separately. Kamu kena anggap dia macam dua benda berbeza lah. So kalau yang moving upwards tu, sebenarnya you can treat that one as it like a ball lah. Contoh kalau ball ni kan, kamu baling dia ke atas, dia naik, dan dia turun bawah. Setuju ke tak?
Setuju.
So kalau kamu baling the object, if you throw it upwards, straight upward, at one point, dia akan stop for a moment. Okay? So that one is the maximum height position. So this is what we call V max equals to 0. Vy equals to 0, sorry. At maximum height, the velocity is equals to 0 for Y component. Kalau X component dia, X component dia adakah 0? Sorry? Okay, dia punya X komponen ni sebenarnya tak berubah. Sebab apa? So, cerita dia sama macam cerita atas tadi. Okay, so yang X komponen ni, UX ni tak kisahlah dia dekat sini ke, dekat tengah-tengah sini ke, dekat sini ke, dekat sini. Dia mesti sentiasa dia punya X dia. Okay.
Okey,
Okay,
faham.
sir.
Kamu nampak tak yang saya tunjuk sekarang ni? iPad saya nampak?
Nampak.
Okay, saya
Nampak.
yang tak nampak diri saya. Masalahnya saya rasa macam berjalan sambil pejam mata. Okay, anyway. Tak apa, kita proceed je. That one is okay. So VY is 0
Tak
because...
faham lagi lah kenapa VY dia tu kosong.
Okay, so kamu kena bayangkan, kalau kamu bayangkan macam ni, kamu faham tak kenapa kat atas dia 0?
Tak.
Okay, cuba kamu ambil satu objek kat dekat kamu. Jangan yang objek keras sama pemadam ke kan. Cuba kamu baling ke atas. Bila kamu baling ke atas tu, kamu akan nampak dia naik atas. Lepas tu at one point tu dia macam berhenti seketika, sekelip mata lah. Lepas tu dia turun balik.
Itu bukan U ke sir?
Dia tak kes.
Oh,
Apa
dah.
you dengan V tu?
Daripada, dia naik ke atas tu V. Okey, saya faham.
Okay.
Sampai atas dia macam stop kejaan tu. U tu kosong lah tu.
Kat atas tu dia kosong. Okay, dia macam ni, kamu jangan susah hati pasal U dengan V ni. Dua-dua ni just a velocity. Satu tu kamu punya reference untuk initial velocity, satu tu untuk final. So bila saya cakap velocity tu, maksud saya tak kisahlah V ke U kan. Bila dekat atas tu, velocity dia tu sama dengan 0. Tak kisah ada starting point ke apa. Kalau kamu release daripada atas, obviously dekat atas tu adalah U. Tapi kita cerita kalau kita baling di bawah lah. Okay tak?
Okey, faham.
Okay, boleh Okay, satu point dah. Okay. Okay, semalam saya pernah cakap. So, if you throw it in this direction, your UY will be equals to the velocity over there. Betul tak?
Betul.
Betul Cuma dia in opposite direction. Okay, the same thing applies now over here. So, kalau this one is the same level, this one is the ground, this one is the starting point. So, dekat sini, the final velocity dia, yang Y component, the same magnitude with the UY. As long as the direction is opposite. But the magnitude is equal. So, I can write over here that UY is equals to VY. Okay. And then another thing, this one, the shape ni sebenarnya yang the middle one ni actually right in the middle. Dia punya maximum height tu betul-betul kat tengah. So if you can measure the SX over here, you can simply multiply by 2 and you can get the total range. Okay, satu benda lah. Okay, let's say if you can get the time taken for it to reach the maximum height, so you can measure this one. T ni kamu dapat kira from here to here and there to there is the same as well. Sama juga. So you can multiply by 2. Faham Dengan syarat tinggi dia kena sama. Sebab ada case dia buat benda ni, cerita ni dia buat atas tepi bangunan contohnya. So benda ni turun bawah sikit. So kalau dia turun bawah sikit, dekat sini yes lah sama. But then bawah ni dia lebih lagi lah, velocity dia lebih lagi, jarak dia jauh lagi. So tu benda tu macam logik lah, tapi kamu kena fikir sikit. So this one, ingat these properties you can use, yang mana SX ni dua ni sama nilai dia, time dia pun sama. Okay, tapi kaedah ni macam tak konvensional sangat. Maksudnya tak ramai orang pakai lah. So sebab soalan dia berubah-ubah, sometimes soalan dia sampai ke bawah, so dah tak boleh pakai konsep tu. Tapi kalau kamu jumpa, bila kamu boleh pakai konsep ni, kamu boleh pakai. Kalau tak, kamu pakai formula biasa pun boleh, tak ada masalah. Okay, so far ada soalan ke tak?
Tak ada sir.
Kita ada, saya repeat lagi sekali kalau UI, kalau kamu ada U, mula-mula kamu kena separatekan UX dengan UI tu, obviously. Once kamu dah separate, you have to treat it separately lah. Kita anggap dia benda berbeza. So UI ni, initially katakan magnitude dia panjang macam tu. Bila dia goes further up, magnitude dia berkurang. Dia makin lama makin slow. Kalau kamu buat slow motion, kamu nampak kot benda tu bergerak makin slow. Eventually at one point, at the maximum point, your Vy sama dengan 0. Velocity Y component dia sama dengan 0. Lepas tu dia turun opposite direction and the velocity keep on increasing. Sebab gravity lah. And then eventually dia akan reach a point. Kalau point tu sama height dia, in this case kalau height dia equals to 0 juga, dia punya magnitude sama. Okay, faham So itu konsep yang pertama. Maximum height tadi sama dengan 0. Itu konsep kedua. Lepas tu yang T dia tu sama tu pun boleh anggap sebagai satu konsep juga. Okay, kalau tak ada soalan, saya simpulkan semua benda ni dalam a table. So basically, maybe I can write a table to compare between Y component and X component. Okay. Y component, X component. Okay, Y component tadi kita ada three formula. The three formula are V equals to U minus GT. I just put this one as Y to separate between X and Y. And then we have V square equals to U square minus 2GS. Again, I put this one as Y. Then we have S equals to UT minus half GT square. Okay. Again, kalau saya salah betulkan. And then on the X component, we have Vx equals to Ux. Okay. And then we just have Sx equals to Uxt. Okay. And the best thing about this is that, kan saya cakap dua ni benda berbeza kan. X dengan Y tu separate. The only time they equals antara dua tu adalah time. So maksud saya time ni adalah penghubung between X component dengan Y component. Okay, if we go back to our situation, contohnya katakanlah kamu soalan dia nak cari dekat sini velocity dia berapa. Nampak tak kamu? Can you guys see this one?
Yes.
Yes, okay, good Okay, dekat position ni katakan kamu dah kira kamu punya V, dekat sini kamu dah kira dia punya Vy, dah dapat jawapan lah Vy. So kamu nak cari Vx. So biasanya kamu kena cari time untuk Vy tu berlaku, and then you can masukkan time tu dalam sini untuk cari dia punya U pula. Contohnya tapi sebenarnya Ux sama dengan Vx. So biasanya bukan macam ni lah situasinya. Saya cuma nak sebut the time tu adalah perantara antara X dengan Y tu. So biasanya dalam exam tak semestinya this one kamu akan diberi lebih maklumat. You will have more information here. So normally you might have to solve the Y component first. In fact, if you look over here, the X component you only have two formula. Biasanya tak cukup. Kalau dikasih soalan yang boleh solve using X component straight away, biasanya sikit sangat markah dia. Sebab direct. So biasanya soalan dia akan paksa kamu pakai this part first. Okay. And somehow you can find the time and then you can relate with this part. Understand or not? Yes, okay? Guys?
Okay, sir, okay.
Okay, sir. Okay.
Okay, sir.
Okay. Okay, saya nak kita cuba discuss satu example. Okay, let's say we try to do example 16. Okay, for this question, a ball is kicked at an angle 37. So first thing kita highlight dulu. With a speed of 30 meter per second. Okay, kalau ada yang kita sebut balik. Okay, calculate the maximum height time of flight and horizontal range of the ball. Okay. Kita tengok soalan dulu. A ball is kicked at an angle 37 above the horizontal with a speed of 30 meter per second. Okay, benda pertama apa yang kamu kena buat?
Lukis.
Lukis.
Cuba lukis. Dah lukis? Lukis kat kepala kamu? Dah. Cuba tengok. Dia tunjuk sikit.
Macam mana?
Kamu lukis kat mana? Kertas ke apa?
Dekat buku.
Oh. Buku boleh angkat?
Nampak tak rasa? Itu bola.
Saya macam nampak sikit-sikit. Tapi Syafiq tak nampak kan. Dia macam
Tak nampak.
Okay, it's okay. Don't worry. Macam betul, saya nampak ada sikit dia punya curve tu. So, okay kot. You guys semua ada idea kan? Dia punya motion mesti macam curve. Okay. Now, saya cuba lukis. Okay, ball. So, I just draw a dot like that. Dia kata dia ada initial speed. Okay, itu U ke UX ke UY? Yang 30 meter per second.
UX.
UX.
Kenapa kamu cakap UX?
Horizontal.
Okay, jangan confuse dengan horizontal tu sebab dia kata a ball is kicked angle 37 degree above horizontal. Okay, itu dia punya angle. Tapi ini dia punya velocity. So the velocity here actually represent your U. Bukan UX, bukan UY, tapi adalah U. So bola tu initially bergerak dengan speed 30 meter per second, 37 degree above the horizontal. So if I want to draw, it would be like this lah. Okay, U equals to 30 meter per second. And then the path tu will look something like this. Okay. Dan kita ada angle, jangan lupa. Angle tu adalah 37 degrees. Okay. So far you guys okay with this?
Yes, sir.
Okay, saya assume dia main bola. So dekat flat surface, dia tak cakap tapi saya assume dekat flat surface lah. Takkan main tepi bangunan kan? So it doesn't make sense. So kita assume dia flat lah, macam padang kan? Okay, now dia kata calculate the maximum height. Maximum height simbol apa sebenarnya dia tanya?
SY.
Yes, good, very good. So this one is your SY. So displacement in Y component is actually your height. Tinggi dia ni adalah height. So this is your height and this is actually equals to SY. Kita pakai SY lah, jangan pakai height, nanti kamu confuse. Dan sebab dalam formula tak ada H kan, so kita pakai SY. Padam ni, pakai SY. Oops, besar lah padam. Pakai SY saja. Okay, now kamu dah lukis, you dah take out information, tapi information yang kamu keluarkan sebenarnya tak cukup lagi. Okay, so whenever you have quantity that's not in X or Y component, kita kena resolve dulu siap-siap. So first thing first, we resolve U tu kepada X dengan Y so that kamu boleh fokus nak buat yang mana satu sekejap lagi. Okay, so we have UY dengan UX. Ingat tak macam mana nak cari UX dengan UY?
Ingat. Cos dengan sin.
Okay, good. So your UY is equals to U cos ke sin?
Sin.
Okay, sin 37 degrees. Okay. Kalau UX, U cos 37 degrees. Okay, so it will be 30 cos 37. Atasnya akan jadi 30 sin 37. Okay, berapa dapat ni? I got here is 18.05. You get something different, please let me know. Oops. 30 cos 37, it will be 23.9.
23.24 boleh ke sir?
Awal sangat nak bundahkan. 23.96. 96, okay. Okay, so kalau masa in between calculation tu, jangan hilangkan pula decimal point dia tu. 2 okay, kalau nak buat 3 pun okay. Tapi tak perlu 6. 6 tu banyak sangat merepek. Okay, okay, now kamu nak pilih formula mana? So we have the 3 formula. In fact, kamu ada total ni ada 5 formula lah. Saya ambil je semua. Then I'm gonna put it here and I'm gonna make it small so that it can fit. Okay. Now, you want to find SY. So, kamu nak pakai Y component ke X component?
Y component.
So, obviously, you want to use the Y component because you want to find SY. Betul? So, between these three, mana satunya ada SY?
Tengah-tengah tau.
Tengah dengan yang bawah kan?
Dua
Dua ni ada
lima.
SY. Okay.
Yang kat bawah
Lepas
sekali.
tu, kamu ada tak UI ada, time ada tak?
Tak ada.
Time tak ada kan? So maybe you can ignore this one lah sebab you don't have enough information. So you left with this equation. Okay. So to do like this, you really have to write down the equation side by side. So I strongly suggest, walaupun formula sheet dah ada, yes, but then formula sheet tu dia hanya kasih dalam bentuk yang V, U, G, T tu, dia general. So why not, once you kamu dapat projectile motion, you write this one side by side and then you can cancel out the equation that you don't need to use. Okay, so we are using the middle one. Okay. Vy equals to berapa?
Zero.
Kenapa?
Sebab dia dekat maksimum.
Yes. Okay. So at this maximum height, Vy is equals to 0. Okay, normally we write this one dekat masa awal-awal tadi kita tulis melukis kan. Biasa kita dah tulis siap-siap lah. So, saya terlupa tapi saya ingat kat sini lah. So this one become 0. Okay, good. Very good. Ui we already have. Ui tu positif ke negatif?
Positif.
Kenapa?
Sebab dia upward.
Yes. Okay. So this one Ui is positive because it's pointing upwards. But in this case kalau dia square it doesn't matter pun lah. Tapi saya tulis je. Kita ambil kira je. But itu cara yang betul lah. We always have to consider the positive or negative. Okay, now you can take the square, 18.05 square. You can bring to the other side. You can divide by negative 2, negative 9.81. You should get 16.61. Did you get the same answer with me?
Yes, sir.
Okay, good, very good. So this one for question A. So, betul kot jawapan dia. Let's check. Tadi jawapan. So jawapan 16. Okay, jawapan dia okay, tak ada masalah. Okay, so far ada soalan tak?
Tak ada soalan, sir.
Okay. So SY this is a so saya biasakanlah tulis balik. So soalan dia tanya maximum height. So normally I will write maximum height is 16.61 meter. Okay. Biasakan jawab tulis balik. Okay, and then sometimes when you calculate you get negative S. So again, I suggest you to rewrite. Okay, kalau negative S tu maybe kamu boleh cakap dia below the starting point ataupun below starting point lah, itu je lah. Tapi sebab ni positif, And soalan dia memang tanya height. So it is understandable. Height tu ketinggian lah, ke atas lah. You don't have to put dia ke bawah ke apa. Okay, number 2, the time of flight. Okay, ada dua cara nak selesaikan this. One, you can use the facts that you can find the time for it to reach this height. So kamu dah ada banyak information kamu boleh cari the time untuk dia naik atas sini. So time dia gerak ke sini dengan time dia naik ke sini sama tau. Yang ini, satu ni, dua ni dengan tiga ni sama time. It doesn't look sama tapi dia sebenarnya sama. Masa dia yang diambil untuk daripada point A untuk X component ke point B, point A ke maximum height ni dengan point A ke maximum height yang Y component je, waktu dia sebenarnya adalah sama. Saya cakap time tu memang antara. Dia tak nampak macam sama tapi dia sama. So jangan pening-pening nak bayangkan sangat ke apa, just anggap dia sama lah. So you can find the time taken for it to reach this height. And then you can multiply by 2, you should get the time of flight. Because the time of flight is waktu dia berada di udara. So from here to here. Itu satu cara lah. You can multiply by 2. But macam saya cakap, ini cara tak konvensional. Okay, ramai orang dia tak terfikir pun ni. So saya tak nak lah buat benda-benda yang pelik. Tak ada pelik tapi jarang orang buat kot. So normally student will take this as our second point. Setengah jam. Tak sempat lah. Apa yang saya buat ni? Lepas ni kamu ada kelas?
Tak ada, sir.
Tak ada. Okay, so kalau saya habis on time pukul ni tak apa pukul 3.
Boleh.
Mak dia ikut sekali. Delete. Okay, ini kita punya situasi tadi sama je. Okay, now dia nak dekat point sini. Okay, this is my V. Obviously V dia akan in this direction lah. Kita ada Vx and kita ada Vy. Okay, tapi dia tak tanya pasal V pun, dia nak cari time. Okay, kalau kamu nak buat, okay, let's say kita tengok balik formula dia kat atas ni. Kamu nak pakai X component ke Y component untuk cari time?
Pakai X.
Okay, kalau kamu nak pakai X, okay, let's say if you want to find time dari dua equation, so obviously you have to use this equation lah. So kamu ada Ux ada, time kamu nak cari, Sx ada tak?
S ada, lupa pula.
Sx tak ada. Okay, kalau tak ada, kita tak boleh. So tak apa don't worry, dalam example kita buat macam ni, kita go through one by one. Sebab normally paling cepat nak dapat memang X component. So normally kita check je, kalau dapat X ni rezeki lah, memang tu dapat jawapan. So just check, kalau tak dapat kita move on to the next one, which is Y component. Okay, Y component, let's say kita nak solve Y component. Kita nak pakai equation mana? Kita pergi balik kat situ. So X tu dah confirm pun tak boleh. Tengok kat sini saya copy yang ni. Apakah ini? Okay, saya akan copy sini balik. Okay, we have dekat Y component tu kita ada 3 equation. Okay, kita nak cari time. So basically we can ignore yang middle one ni sebab middle one tu tak ada time. Okay, now which one yang kamu nak pakai?
Atas sekali kot.
Yang first tu.
Okay, kalau nak pakai atas sekali, Uy kamu ada. G ni adalah time kamu nak cari. Vy ada?
Ada.
0.
Sure. Okay, kalau Vy dekat sini ya 0. Oh, kamu nak cari time ni ke? Kalau nak cari time ni boleh je. Kalau kamu cakap Vy dia 0, maksudnya kamu kira from here to here. Faham tak? And then you have multiply with 2. Okay, boleh. Tak ada masalah. Okay, alternatively, you can measure from here to here straight away by using, saya sebenarnya tak suka buat macam ni sebab students biasa lupa darab 2. Sebab tu saya tak galakkan student buat. So kalau memang ingat tak apa. So biasa dah buat, lepas tu tinggal gitu je. Okay, anyway, kalau kita consider straight macam ni, sebenarnya kita boleh tahu juga Vy dia tu berapa. Vy dia berapa kat sini saya? Ingat tak saya punya properties yang asal-asal tu saya ada sebut beberapa properties.
Vy sama dengan Uy.
Yes. Tapi direction dia opposite, betul? Okay, very good. So you can say that Vy sebab dia punya height tu sama tinggi This is the specific reason. This is the specific example, specific situation. Dia tak apply dekat across semua benda Dekat sini yes, sebab height dia sama tinggi. So you can say that Vy is actually equals to negative Uy. Negative because they opposite direction. So Uy tadi adalah 18.05. So this one is negative 18.05. Okay, so now we can use the first equation straight away. Masukkan negatif tu, jangan lupa. Uy is positive. Minus 9.81t. Now we can solve. So 18.05, you bring it to the other side. I got here is 3.68. You get the same answer?
Sama sir.
Sama Okay. And the last question, they ask you to find the horizontal range of the ball. So the last question sebenarnya apa? Simbol apa ni? S. Apa kalau nak specific? Range S apa? Yes, SX. So SY ke atas, SX dia punya range. So this is your SX. Okay. Again, so copy everything. Oops. Okay, so now you want to find your SX, which is basically this part. Okay. So SX, kamu nak pakai X component ke Y component punya equation?
X component.
Yes, component. So you only have two. Obviously, kamu pakai yang second one je lah. So SX equals to UXT. Substitute. Okay, UX is equals to apa tadi? Sebab tu kamu buat awal-awal ni bagus tau. Sebab nanti kamu tinggal nak ambil je. And then sometimes bila kamu kira ni, katakan bawah ni kamu buat semua salah kan? Most of the time kamu mesti dapat satu markah dekat sini. Sebab benda ni memang kena pakai, kena buat. So 23.96. So buat di atas ni. Time tadi 3.68. Okay, perasan tak? Time ni tadi kita kira untuk Y component. So maksudnya waktu dia naik dengan waktu dia turun balik, waktu dia adalah 3.68. But at the same time, dia actually gerak this direction. Dia cakap X dengan Y tu perantara dia adalah time tu. So you can use the time, substitute. .17. Okay. Faham?
Faham saya.
Okay, good. Okay, konklusinya, student biasanya masalahnya yang biasa saya nampak lah dekat time tu. They didn't see the correlation. Dia tak nampak perkaitan X dengan Y tu macam mana nak kaitkan. So they confused. So masalah perkaitan ni, solution dia senang je. Kamu buat side by side dia punya equation tu. So information tu kalau kamu dah keluarkan lengkap, kamu letak side by side, mana yang kamu rasa tak boleh pakai, potong je equation tu. And then sepatutnya tak ada masalah. Kamu blur macam mana pun sepatutnya masih boleh jawab. Itu satu point lah. The second point, banyak yang student masalah sebab ada information yang hidden. Soalan dia nampak ringkas dia macam ni. Okay. Tapi ada banyak hidden information yang biasanya kalau yang contohnya Vy sama dengan 0. Lepas tu yang tadi tu bila dia jatuh tu, dia punya velocity tu sama dekat sini. Okay, benda ni semua dia tak sebut dalam soalan. But you really need to know lah. So the only way kamu nak tahu masa bila kamu nak keluarkan maklumat ni semua dengan cukup latihan. Itu je. There's no ada shortcut lah. Tak ada shortcut. Kalau tak memang tak terfikir. yang dekat maximum height itu adalah 0. Tapi kalau kamu dah biasa buat, kamu dapat soalan je, okay, Vy 0. Senang. Okay, dia kata range, senang je. Tak ada masalah. Okay, ada soalan tak? Kalau tak ada, kita berhenti dulu lah.